Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are going to implement Q-learning with an RBF network to solve CartPole. If you don't want to code along, although I highly recommend you do, the relevant file in the course repo is qlearning.py in the subfolder CartPole. At the top, we have all our usual imports. You'll notice the feature union, standard scaler, and RBF sampler from last time. We're also importing the running average function from our previous script. Next, we have our SGD regressor. Very simple class. Each function is basically one line. In the constructor, we initialize some instance variables. In partial fit, we do one step of gradient descent. And in predict, we return the dot product of the input with the weights. Next, we have the feature transformer, which is subtly different from the one we use for mountain car. Instead of sampling from the environment, we're sampling from a uniform distribution around the points we think will be good representatives of what we'll see during training. We also want to keep track of the number of dimensions so that we can initialize SGD regressor later. Next, we have the model class. This is pretty much the same as before as well, except the constructor for SGD regressor is different because we wrote it. It now takes in the dimensionality of the weights. Remember, we have one SGD regressor for each action. In predict and update, this is an alternative way of converting a 1D array into a 2D array. This is because in our SGD regressor class, we want NumPy arrays and not lists. Next, we have the play1 function. This is also pretty much the same as before, except we're going to stop at 2000 iterations. Our model can potentially get really good at keeping the pole balanced, so we don't want this taking forever. Notice how we still have this reward hack to give the agent a large negative reward if the pole falls down, and that we are still doing Q-learning. Next, we have the main function. This is all stuff you've seen before. We play a bunch of episodes, update epsilon as we go, keep track of the total rewards. We then plot the total rewards and the running average so we can see how consistent the agent is. Let's run this and see what we get.